to live in a time where things are turning over. They're turning around pretty fast. And before I forget, let me give you the bad news, right? All of us are familiar with everybody's talking about the Icelandic volcano, right? Because it erupted. Everybody's talking about that. But we have a problem. We have a problem. From the start of the eruption to this very moment, there's not enough magma being released. Not enough. This simply is not enough. And there's almost, I guess you could say there's almost a reverse pressure effect taking place. So if we see that magma decline sharply within the next 30 hours, that just spells bad trouble. It really does. Keep in mind, when a volcano goes, that means the pressure of that magma overwhelmed the chamber, whatever conduit it sits in, until it finds a relief point. In this case, it was at the surface. All the earthquakes and all that momentum of the earth, if you were to convert that movement into joules, you would find out that that was a lot of energy. And if you ran some simple calculations, you'd find out what mass it would take to cause that many joules, right? What it would take. Well, you find out that the magma being released is nowhere near what's necessary to quiet that area. So we have a problem. I believe, and I'm probably not alone in this, but as magma was being released, it was being blocked. Something is blocking it, which means there are pathways that magma is forging its way through, right? And the relief point that we see in Iceland is only just that, a small relief point, a very tiny relief point. So, folks, there's a bigger problem stirring. There really is. And this bigger problem could really mean, it could spell trouble for quite a few places, quite a few things, right? We're talking about a lot of magma. And if you know how Iceland is constructed as far as its the unrest in those magma chambers and how they're stacked on top of each other, and because there are lots stacked on top of each other in that area, you know that all the magma coming out only represents a tiny, 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 tiny fraction. It's almost like if you were to open a soda, right? Then if one drip came out, that represents the magma you see. By no means does it represent or constitute the sheer volume of magma in those chambers, right? It does not reflect the pressure that's continuing to build up lower in the earth. That's part of the problem. You have magma coming out, but the pressure is still building underneath, right? That's not supposed to happen that way. Not supposed to happen that way. If you have an eruption, right? If you really have an eruption, it should relieve the pressure. All the sensors should reflect relief in pressure. Unfortunately, that's not what's happening at some of the lower chambers. And so this could be the beginning of an issue that we're just simply going to have to deal with. Because the earth is absorbing, is really taking on lots of radiation from the sun, which radiation means energy, right? Lots of different types of energy or radiation from the sun. It is essentially getting hotter internally, which melts more and more rock material, which causes more and more eruptions. But we don't have enough relief points. And if you don't have enough relief points, which means eruptions, we're going to see a lot more earthquakes. Earthquake patterns we've not really, some people have seen them. Those who study earthquakes have no doubt seen the patterns. They have been an enigma up to the very time they start, giving way or blowing. But the sound waves from those earthquakes are traveling all around the planet. They're traveling in these known patterns. And at some point, especially in California, Northern California, for example, they have dormant volcanoes up there where they used to be dormant. They're waking up now. Those are potential points where magma can exit the Earth, right? Southern California is highly populated. Unfortunately, there are areas in Southern California that could also do the same thing. But in this case, it's going to start rumbling that ground. And we all know what would eventually happen if California, if that ground shifts a little bit, you're going to have some pretty disastrous earthquakes. So don't be surprised if all the experts begin to talk about earthquakes again in Southern California with urgency. Don't be surprised. What's happening in Iceland represents something that will happen all around the Earth, right? All around the Earth. So it's not going to stop. And it's just like your cell phone battery, right? Or some device battery. The more you charge it, the more you alter the chemistry, the more potential energy it stores, the hotter it gets. Same thing is happening to the Earth, right? So we actually have the Earth emitting radiation it has not emitted before, right? That's partial reasoning for some of this these warm climates that we have. And the sun, of course, is reacting from something outside of our heliosphere, which you guys know what I believe it is. It's going to continue to do that. And I know that we're in a active solar cycle right now, but that's not going to constitute some of the activity from the sun that you guys are going to see, right? It will by no means explain the weather phenomena that we're about to endure. It's not going to explain it. And I know I've said this lots of times, but to have floods and droughts at the exact same time, this is going to become quite prominent. It is prominent now. It's just that nobody is reporting on it. But it's going to become prominent in a way that you guys will start to feel the impact of these changes. For a long time, it's just been information, right? For the majority of people, it's just been information. You learn a few things here, a few things there, hear this theory, that theory. We're getting beyond that point, where the impact or the cause of these changes is going to take its toll on the average person. So now it will begin to affect all of us in a very notable way, right? And Iceland will stand as a good example of that. Because in all truth, if this pressure continues to build, it has one or two places, or one or two things that can happen. If the pressure builds going downward, we can actually have a dislodging of a landmass, right? Because we're not talking about a magma chamber in a small hole. Nope. No, that is not what the visual imagery looks like at all. In fact, the visual imagery looks more like an ant nest, right? That's what or a termite, the insides of a termite mound is what they look like with hundreds of chambers going all over the place is what it looks like. And they are hot, under pressure, right? And below Iceland sits part of that in the Earth Ocean. And we don't want that to come out. That's superheated water, by the way. So, within the next 30 hours, if all of a sudden that volcano, if that magma decreases rapidly, then in truth we had no event whatsoever. We just saw a little tiny piece, right, of some of that magma come out. It by no means represents some of the chambers that are internal. The one that shut down the air traffic in Europe, right, that was only possibly, if I could compare it to something. If your hand, one of your hands was one of the chambers, you hold it out flat, that eruption from Europe was your fingernail, your pinky fingernail. That would be a pretty good comparison of what it ejected and what it caused. All of that came from a fingernail size amount or volume of magma, right, being evacuated from that volcano. This is even worse because this doesn't represent a fingernail size. Well, one good thing is that it is indeed magma. The bad thing is it's not enough. Just is not enough. We needed a much larger eruption. right? It's kind of like having a full tank of gas, and you take a small pin and you put a hole in it. Well, that gas is going to trickle out. It's not going to gush out, right? It's going to trickle out. If, however, you were going to run your car into a fire, you'd want all that gas to come out as much as you can so nothing else happens to it, right? So that gas doesn't ignite. But with a trickle, you're still going to have that potential of danger. This volcano is the same way. If a lot came out, and it would disturb at least 1/4 of the earth, we could say, okay, we have a good relief point. But we still, to date, we don't have good relief points. For the sheer amount of energy that the earth is consuming, or storing, I should say, that's heating up the planet, there's just simply not enough relief points. And so to summarize this, is to say this: the energy we're taking in is being changed, of course, right? But it's causing too much magma, which cannot, all of it, it just cannot. It doesn't have enough relief points to stop some of the earthquakes that it's going to cause, to stop some of the super eruptions it will cause, right? It's not enough relief points. We need many more volcanic eruptions. We do. But we don't have those. And so the earth is going to continue to heat. The seas are going to continue to get hotter and hotter. This year, they said that the oceans were the hottest they've ever been, right? It's astounding how that doesn't even, nobody's interested in that. Because for the most part, they don't really understand what that means. They briefly talked about sea life. We're losing a lot of sea life. Deep dwellers are being driven up, boiled to death. Large squid and the like. New species are being seen all over the planet. Large specimens, right? Large crustaceans, which when they surface, of course, they can't adjust themselves to the pressure. And so they only survive for a little while and then they die. Some of your larger species are not like that. So Earth is changing rapidly. And all of that, I believe, because the Earth is taking in too much energy, right? Too much radiation. It processes that, right? The sun is constantly, just in case you don't know how it works, solar winds from the sun are always hitting the Earth by way of the magnetosphere, right? That radiation is redirected to the poles, taken into the planet, and that energy is converted into heat, into magma, into all sorts of different things, mostly magma, right? And it has to have a relief point at some point so that the Earth does not shake itself apart. If we don't have enough eruptions, we're going to start having some pretty big earthquakes. And we're talking about having earthquakes of possibly a 6.0 that will last for 15, 20, 30 minutes, right? And before you say that's impossible, that's already been noted in several places in the world, even the USA. And we're getting closer to that mark, and we simply don't have enough relief points. You'd be like overfilling your car tire, right? You overfill your car tire, you're going to bust a seal. You're going to have a big bulge somewhere. But if that fails, that tire is going to explode, right? The volcanic eruptions would be the bulge where the air leaks out just a little bit, right? It'll damage your tire, fine. Causes a bulge, fine. But it doesn't blow up and hurt you in the process. In this case, there are no bulges. And it's still taking on air. So it's only a matter of time before it can no longer take that much pressure, and poof. That's what happens, right? Earthquakes are a telltale sign of shifting that's taking place in the Earth in a lot of cases if the pattern is right. You're dealing with low frequencies, so the pattern must be right. It must match, right? Very, very LF-type waves. But what most people are saying is that the Earth continues to take on more and more radiation, charging. More and more galactic cosmic rays, which affect the sun and us. There are no relief points, not enough earthquakes, not enough volcanic eruptions specifically. And it's all going to come out one way or the other, probably at the wrong time. In fact, in prophecy, as we continue to read through prophecy, you can learn about the conditions of the earth. One thing I'm going to point out are the conditions of the earth. I know a lot of people think they're going to make it all the way to the end of Revelation. I beg to differ. I do. The conditions on earth are going to be incredibly inhospitable. And the Lord explains that too many times, right? Not to say you're going to be in that time, and that's, none of us are here to endure the wrath of God. Do you know why? Because you would not know who Christ is, nor would you believe in Christ if you were here to endure his wrath. His wrath is against those who knew the Son and rejected him. That's very important. Not those who never knew him, but those who rejected him. Everybody has their moment of their honest moment when they really know who Christ is. Now I'm going to ask you something. What heart is it that would understand the sacrifice of Christ, that would truly have understanding of what he did, that would truly have understanding of their own life, to really know exactly what Jesus did? I'm talking about not by somebody's lips, but God making clear the matter in their minds and hearts. What type of a person would reject Jesus and reject the gift of salvation? What type of person would do that? Those are the people who are appointed to his wrath. Those are the folks who will be going through some things in that time of wrath. You're not here to go through his wrath. You're here to be raised. You're here to become something just like Christ. He is the first of many brethren, like a brand new species in eternity. That's what you are. You're not here to be punished. You're not here to go through lots of people use scare tactics, right? They do. And sometimes they don't know they're doing it. A scare tactic is when you somehow believe that you're being punished. No. Like a good father, the Lord will correct us, but everything he does is for the sake of our souls. Think about that. If for some reason your life has gone upside down temporarily, the Lord is concerned about your soul. Because what happens if he's very lenient and your soul is lost? Then you're lost for an eternity.